All right, here we go. Question number 10 from our Precalculus, homework number 11. In MyLab Math, we have a GeoGebra problem. It says write an equation of a parabola given its directrix and focus. So let's click the link. And here we can see it says move the 2 points to define a parabola and then write its equation. So here, given the focus and the directrix, we're going to have to come up with the equation of the parabola, but we are allowed to move these 2 points. So I highly recommend, if you can, move the directrix so that it is on an axis. Now what this is going to do is this is going to make your value 0. See, it says x equals 0 for the directrix, and that's going to make the calculations easier. Now the other thing that you want to do, if you can, is move the focus so that it is also on an axis. And again, what that is going to do, that is going to align the vertex, the directrix, and the focus all on an axis, and therefore making your calculations easier. So from here, what we need to do is we need to make a couple of notes of what the directrix and the focus are, and then we're going to go look at the appropriate formulas. All right, so here in my scratch work, I've got my directrix written and my focus. From here, what I need to do is remember whether the parabola opened up, down, or left, right. So going back to our parabola, we can see that this does open to the right. And here in our parabola information sheet, at the bottom, you can see that the column that we're going to choose to work with depends on whether the parabola opens up or down or left or right. And so what this means, since our parabola opens to the right, it means that it will have a horizontal axis. And then all of these formulas apply to our particular parabola. All right, so back to our scratch page, what I've done here is copied some of the formulas from our information sheet over, knowing that the directrix is h minus p, but you can see our directrix was equal to 0, and so we can actually extrapolate an equation from that. That would say that h minus p is 0. Also notice that from the focus, h plus p is the x-coordinate of the focus, which our x-coordinate was 6. And so again, we can extrapolate an equation from that that would say h plus p equal to 6. And then if you remember solving your system of linear equations, we now have a system with 2 equations and 2 unknowns, and we can solve for h and p. And if you're wondering about k, k is super easy because see, k is isolated here. The k is the y-coordinate of the focus, which is 0. So we automatically know k is 0. So, using the addition method, we're going to get 2h, our p's cancel, equal to 6, divide by 2, and now we have h. h is 3, writing that down, and then we're going to come back up to here and plug in for h. So if h is 3, 3 plus what is 6? And that's going to tell me that p is 3. Once I know h, k, and p, I can write the equation. So the equation of our parabola will be y minus 0 squared equals 4 times 3, x minus 3. And then simplifying, y minus 0, that's just y squared. 4 times 3 is 12, x minus 3, and this should be the standard form of the equation of our parabola. And back to the GeoGebra window to input our answer. That was y squared. Now to do a squared, you can do Shift 6 on the keyboard, or you can grab the keyboard in the window and do a squared. Either way, y squared equals, click in the other box, that was 12x minus 3, and then we need to close this, and let's check and see if we're right. Yeah, correct. So let's try another and see if we get a horizontal directrix, and then we'll do another example. All right, so we did get another parabola. This one opens down with a horizontal directrix. Again, to go through the steps to solve these kind of problems, we are allowed to move the 2 points to define the parabola. Remember, I said I highly recommend that you move the directrix to an axis if possible. And the reason you want to do that is to make your calculations much easier. So our directrix, I'm going to set that to y equals 0. And then I'm going to move the focus over onto an axis. And then that should give us a nice distance from the vertex to the directrix to the focus. Again, do you see how those all line up on a line perpendicular to the directrix? And again, that should make your calculations easier. Okay, but wait a second. On a side note, I believe you can move this focus. Yeah, you can move it up and down as well. And if you notice, if I leave it here at 0, -5, do you see that the vertex is not going to be at an integer value? So again, be careful about that, because if you're allowed to choose where the vertex lands, you want to make sure that your vertex is at an integer, again, just to make your calculations easier. And so I'm going to leave my focus at 0, -6. I don't know if you can tell that, but that also gives me the vertex. So if you have that information, that's going to save on our calculations as well. All right, so let's do this. Let's go to our scratch work and make a note of the directrix, the vertex, and the focus, and then we'll go look at our information sheet. Okay, so in our scratch work here, I've written down our directrix, our focus, and vertex, which this is a different approach than what we did in the previous example. And you're not always going to be given the vertex. Sometimes it might be hard to find it, but in this case, since we could locate the vertex, that's going to make our life much easier. And if you recall, this parabola opens down, so we want to go to our information sheet and look at the formulas that apply here. Okay, so for opening down, up or down, we can see the directrix is y equals k minus p, and the focus is h comma k plus p. And the vertex, notice, is the same either way, h comma k. Let's go back to our notes and, well, make a note. All right, so back on our information sheet here on our scratch work, I've written down the formula for the directrix and the focus. And again, this special note that we do have the vertex this time, I want to address that immediately. Notice that that does give us the value of h and k. So the only piece of the puzzle that I need to find is p, and that is going to be super easy if I use the directrix information. We can see that k minus p, in our case, should be 0. So making a note of that k minus p is 0. But see, look here, we know what k is. So I can replace k with -3 and solve for p. Moving the -3 over, that's going to make that +3. And then if I change the signs on both sides, we can see that p is -3. And now that we have all three pieces of the puzzle, now we can write our equation. So our equation will be x minus 0 squared equals 4 times -3, y minus a negative, look at that, minus a negative, we'll make that a +3. And then to simplify, x minus 0, that's just x squared. 4 times -3, that's -12. Y plus 3, and that should be our equation in standard form. And now let's go back to the GeoGebra window to see how we did. All right, here we go. Inputting our answer. X squared equals -12, parentheses, y plus 3. And then we're going to scroll down and check. Yes, and we're done. And that, I don't know if you noticed, but that covers both vertical and horizontal directrix. And I hope that helps, okay? If you have any questions or comments about anything that I've covered, please feel free to leave those in the comment section below. Or you can text me, and thanks for watching.